All right, hello and welcome to day 2 of Math with Miss Lastly videos. Yay! Okay, so today's lesson we're going to be looking at some word problems with trigonometry. We're going to start with angles of elevation and depression. That should be a nice review from geometry, and then we're going to look at another type of trig word problem. Today we're really just practicing some problems where we're going to be setting up some right triangles. We're going to be using some trig. There's not really one exact type of problem, but I know I put a couple elevation depression ones in there, so if you forgot that vocab, I kind of wanted to go over it. But really this is just a mix-up of different types of applicable trig problems. So, word problems, everyone's favorites. Here we go. All right, so like I said, we are starting with angles of elevation and depression just to refresh your brain on what those are. And then we're going to kind of get into it. So hopefully you have your guided notes handout. Now we're just going to start going through these. So the angle of elevation is the angle using the ground as the horizontal line, and it's the angle looking up. All right, so our angle of elevation using the ground as the horizontal. It's the angle going up. All right, so that is your angle of elevation. Whoo! It is 11 o'clock at night right now, so cut me some slack. It's hard to talk. Plus, I'm trying to be quiet because there's a baby on the other side of that wall right there, and I don't want to wake her up because that's going to make this whole process take longer. Cool. All right, so that's our angle of elevation. So then angle of depression, all right, so instead of using the ground as the horizontal, it is actually using the skyline as the horizontal. All right, so your angle of depression uses the skyline as the horizontal. All right, and then from that skyline horizontal, it is the angle looking down. All right, so it is the angle going down. All right, so I've provided 2 pictures for you in case those definitions weren't doing it for you. And so you can kind of see the angle of elevation. You have the people on the ground and they are looking up. You have that horizontal line, which is parallel with the ground. And then your line of sight is that angle of elevation. All right. However, angle of depression, you're standing up high, you're using the sky as your horizontal, and then you're looking down to whatever object is below you. So that is your angle of depression. Now, what I will say is the angle of elevation and the angle of depression. So if you remember anything from geometry, aside from the 3 angles of a triangle add up to 180, hopefully maybe it was something about parallel lines. So the sky and the ground are parallel to each other, meaning they're never going to cross. If the sky and the ground do cross, then math is the least of our worries. So anyways, since we have these 2 parallel lines, and our line of sight is essentially our transversal. So a transversal is just a line that cuts through 2 or more other lines. So our angle of elevation and depression are actually have a special name. They are called alternate interior angles, and they are congruent to each other. So this would be our angle of depression. This would be the angle of elevation, right? So they are actually congruent to each other. If in my angle of depression one, I wanted to make that ground line and have a triangle going this way, like that, my angle of elevation, so the angle that the people in the boat are looking up to the guy on the top of the mountain, is the same angle as the guy who's looking down at the people in the boat. So the angle that they're looking at is actually the exact same angle because the sky and the ground are parallel, making those two angles equal to each other. So a lot of problems are going to have maybe generally what happens is angles of depression, people tend to want to go ahead and rewrite them as angle of elevations, and you can do that because they are always going to be congruent to each other. So just fun fact, a little bit of geometry for you guys. Now, you know, we're doing trig, so geometry was inevitable. Okay, so here's our first question. This is a very straightforward angle of depression problem, right? So it says the angle of depression of a buoy from the top of the Barnegat Bay Lighthouse. Cool. 130 feet above the surface of the water is 6 degrees. All right, so this is actually giving you a picture, so it's even super easier. All right, it wants us to find the distance x from the base of the lighthouse to the buoy. All right, so we know that the lighthouse is 130 feet. We're trying to find this x distance in the water. So this is one of those instances where they give me an angle of depression, but my triangle is really actually more set up for using an angle of elevation. But that's okay because I know that this angle and this angle are congruent because of parallel lines. So this theta is also 6 degrees. Now that I have theta, I'm kind of looking at my triangle here. I see that x is the adjacent side to my angle that is 6, whereas 130 would be the opposite side. All right, so then I ask myself, okay, I have adjacent and opposite. What trig function is going to best suit that? And that's going to be tangent. So I'm going to do tangent of 6 degrees equals opposite over adjacent. Now my game plan is to go ahead and solve for x. So multiplying both sides by x and then dividing by tangent of 6 gives me 130 divided by the tangent of 6 degrees. Now I can do nothing else by hand. I must go to my calculator and I'm going to type in 130 divided by tangent of 6, enter, and that is going to give me 1236.87. And what are we in feet? Perfect. There we go. And that's the answer to the problem. That's all I gotta do. So it's a very straightforward angle of depression word problem. Now, the next one is not as straightforward and does require some substitution. So this one is kind of looking at angles of elevation and depression, but really it's just a trig word problem that we're going to kind of go through. All right, so it says a large helium-filled penguin is moored at the beginning of a parade route awaiting the start of the parade. 2 cables attached to the underside of the penguin make angles of 48 degrees and 40 degrees with the ground. All right, so I'm going to go ahead, and I already have my penguin picture. You're welcome. I had to Google that. It didn't come with the penguin. All right, so anyways, I thought it would make it more fun. So I'm going to go ahead and put my angles in here. All right, so it says 48 and 40. All right, so 48 is going to be this angle, 40 is going to be this angle. If you're wondering how I knew that, it's because the angle that's closer to the building is going to be a bigger angle than the angle that is not building, the penguin, right, further away from the perpendicular line. All right, that the angle that's closer has to be bigger because it's opening up wider. The further away you get, the narrower your angle is going to be. So I know that the 40 is the second one, or I guess the first one if you're reading left to right, and then 48 is the innermost one. All right, so 2 cable, all right, with the ground on the same plane, blah, blah, blah. If the cables are attached to the ground 10 feet from each other, how high above the ground is the penguin? All right, so we are trying to figure out this. I'll do h for height because I'm going to probably have another variable in here. Now, am I guaranteeing the method that I'm about to use is the fastest or only method for figuring out this problem? No, I'm not saying that, but I am saying that it is one method that you can use to do this. So, and this is using trig. All right, so first I'm going to need to label some more information. So this piece is the piece that's 10 feet. So it's only talking about that part right there, right? It's the two cables, how far they are away from each other. I need another variable to represent this side of my triangle. So I'm going to call this piece X so that I know that the base of my bigger triangle right here is going to be 10 plus X. Now that's important because I'm going to start setting up some ratios. So I have the hypotenuse of these triangles is not involved, so that means I'm going to be using tangent. So I'm going to do the first triangle, so tangent of 40 equals height over 10 plus x, which is the adjacent side there. And then my other triangle, tangent of 48, is going to be h over x. Now you might be wondering, Miss Leslie, this looks stupid. We have two variables in our equations. That's okay, we have two equations. All right, anytime you have two equations and you have two unknowns, this is definitely solvable. All right, so what we're going to do is isolate one of these variables and solve for the one that we didn't isolate. All right, I'm going to go ahead and isolate h because that looks way easier than isolating x. But to each his own, do what you feel is right. Isolating x is going to be more challenging. So I'm going to do just h. So in my tangent of 40 equation, all I need to do is multiply both sides by 10 plus x. All right, so I have h equals 10 plus x tangent of 40. Cool. In my second equation, it's even easier. I'm just going to multiply both sides by x. So h equals x tangent of 48 degrees. Now, transitive property says if h equals this and h equals that, then those two things must equal each other. So 10 plus x times the tangent of 40 equals x times the tangent of 48. All right, so now the game plan is to solve this. So I'm going to go ahead and I need to get everything that has an x on one side of the equation and everything without an x on the other side of the equation. All right, did I fix it? Yeah, cool. All right, we were just having technical difficulties here, but it has been resolved. I think anyways. Okay, so where were we? All right, we're going to solve this for x. Now, you might be wondering how to do this. Well, we have done so much practice on this skill. We did it when we were isolating variables in Unit 1, when you had those, equations where it's like a bunch of things all jumbled together and you had to like isolate just one of the letters. We did this last unit when we were doing reciprocal or inverse functions with the rationals, and we're going to do it again. All right, so if we're trying to isolate a variable, we're going to be using some GCF is going to come into play here because there's a lot of multiplication and I need to fish out all of those x's. So step one here is actually going to be to distribute the tangent of 40 into the 10 plus x. So I have 10 times the tangent of 40 degrees plus x times tangent of 40 degrees equals x tangent of 48. Now I'm going to move everything that has an x to one side of the equation, which means I'm going to go ahead and just subtract x tangent of 40 over to the other side, leaving me with 10 tangent 40 equals x tan 48 minus x tangent 40. Now, I notice that both of my terms over there on the right-hand side have an x. I'm going to factor that out. So 10 tangent 40 is x parentheses tangent of 48 minus tangent of 40. Now I can simply divide both sides by that disgusting thing over there. So tangent 48 minus tangent 40 on both sides. Tangent 48. Boom. Okay, so now I know this doesn't look pretty, but this is what x equals. Now I am going to go into my calculator and turn this into a number, but just remember, tangent of 40 and tangent of 48 are just number values. I'm choosing to leave them as tangents because I want my answer to be as exact as possible. So anytime we're doing problems, you always want to wait to the very last step to plug it into your calculator, because the more you round, the more off your answers are going to be. So even though it looks gross, just remember all those tangents of some angles are some number value. It's a number. All right, so just keep that in mind. All right, so here we go. So tangent 10 times tangent 40, cool, divided by tangent 48 minus tangent of 40. All right, so I got an x value. Are we still able to? Okay, so this equals 30.9. Right, so that is my x value, which is actually not the final answer, right? So this equals 30.9. Now, I also want to find the height of the penguin. That's actually what I was looking for. All right, now I don't need to do anything crazy. I've already set it up. I'm just going to plug in my x value into either one of the two equations that I started with. So this one or this one. I'm going to choose to do the easier of the two, which is x tangent of 48. So x is 30.9, and I'm multiplying that by the tangent of 48 degrees. Now I'm not actually using 30.9, I am using the exact value that is in my calculator. So I'm just going to say times and then tangent of 48. And that's going to give me 34.3 feet. Is that what we're in? Yes. Bam. And that is your final answer. So no, this wasn't necessarily an angle of elevation problem, although both of those angles that were given on the ground are angles of elevation. All right. Anyways, this is just trig problems. So you're looking at problems where right triangles are going to come into play. You're going to be using sine, cosine, tangent. Some of them might be angles of elevation and depression. They might not be though. They might just be problems where you are trying to use trig ratios to find the values in a right triangle. All right, have fun with your word problems, and I'll see you in the next video. Bye guys.